Hello everyone, back for lesson number 3. Today we're talking about exponents. When you're talking about exponents, first you have to know that the number itself is called the base. The little number is called the exponent. The exponent tells you how many times you're multiplying the base. So 10 to the second power, which is how we say this, would actually mean 10 times 10. And 10 times 10 equals 100. So 10 to the second power equals 10 times 10 equals 100. And notice there's a lot of really neat things here. The exponent will also tell you how many zeros you're going to end up with in your answer. And when you spread it out, 10 times 10, you'll also have 2 zeros. And it's just ways to kind of check yourself. So let's do a little bit more with exponents. Remember, when you're doing with exponents, a lot of times people, when they see the base with an exponent, they get confused on what you're actually multiplying. When it's 10 to the first power, you're basically saying 10 times 1 equals 10. The exponent is 1, so you have 1 0, 1 0. Okay? 10 to the second power, we just talked about, equals 10 times 10 equals 100. 2 zeros, an exponent of 2. 10 to the third power, you're probably guessing by now, is 10 times 10 times 10 equals 1,000. And you'll notice from back from lesson 1 with the base 10 system, this is all very fancy how this works out. The exponent is 3, and you have 3 zeros. We're not doing this in this lesson, but I did want to show you that the base number won't always be 10 or 100 or 1,000. That's what we're doing in this lesson. But you can have a base of, let's say, 6 to the second power. And 6 to the second power would be 6 times 6, and it would equal 36. So exponents don't always have 10, 100, or 1,000. But in our lesson, that's just all we're working with right now. Okay, let's go and do a little bit with division now. Okay, let's say we're doing, how about 100 divided by 10 to the second power. The first thing you always have to say to yourself is, well, what is 10 to the second power? And you know it's 10 times 10. I'm going to put that in parentheses down here. And we know 10 times 10 is 100. So we're saying 100 divided by 100, which actually wasn't a very good problem for me to do, but that's okay, equals 1. Because 100 times 1 equals 100. Sometimes with division, if you turn it around to multiplication, it helps you think of the answer. Let's do a little bit better of a number, though. How about 700? I'm going to put my decimal point, because it's a whole number, so I know my decimal point always goes where? That's right, at the end of the whole number. 700 divided by, let's do 10 to the second again, equals, again, I have to think to myself first, what is 10 to the second power? 10 times 10, and I know that that's 100. I know I'm dividing, so again, I know my answer should decrease in value. So 700 divided by 100 equals 7. There's also a neat trick when you have 2 zeros here. You can cross off those 2 zeros and cross off those 2 zeros, and it will give you the answer. And again, that works when you're dividing by 10, 100, or 1,000. So exponents are basically pretty straightforward, pretty easy. You're looking at, let's clear this off, you're looking at the number, you're looking at the base, you're looking at the exponent, you're thinking to yourself, what does that equal? 10 times 10 is 100, times 10 equals 1,000. Again, if you count the number of zeros, it should match your exponent. So that's actually pretty, like I said, pretty straightforward. let's talk about patterns, though. In this lesson, we also looked at when you have patterns. So let's do just kind of a simple pattern, because if you can do a simple one, you can do a complicated one, because you just have to follow the same steps. And that's the key in math, is following the strategies, following the formulas, and doing it the same way over and over again. Even if you think you can do it in your head, you want to follow the strategies, because you're going to get to a point in math where you can't do it in your head. But if you're used to following the strategies, you're just right there. You're ready to do it. When you're doing patterns, the first thing you want to notice is my value increasing or is my value decreasing in value? Well, when I look at this pattern, I know that this pattern is increasing in value. Okay. The second thing I want to look at is how much is it increasing by? Well, if I look at 3/100ths increasing in value to 3/10ths, I know that that's a times 10, because the 3 went from the hundredths to the 10th place. And then I can look here, because you want to continue on and make sure your pattern continues for the entire problem. The 3 went from the 10th place to the 1's place. Here the 3 went from the 1's place to the 10's place, from the 10's place to the 100's place, and from the 100's place to the 1,000's place. So I feel pretty confident that my pattern was increasing by 10. So if we know it's increasing by 10, what would the next number be in our pattern? Let me put 3,000 here. We're increasing by 10, so I know my next increase would be to 30,000. Let me look at my zeros. 1, 2, 3. 1, 2, 3, 4. That looks right. This was in the thousands, and now it's in the 10,000s. And because we have our place value chart memorized, which I know everyone does, they know that that is correct. Okay, so take your time on patterns and look for what they have in common, and just follow the steps. Increasing in value or decreasing in value? Increasing by how much? And then make sure it fits the pattern the entire way across. And that's basically it for this lesson. Let's just go back and do one more exponent to say goodbye. How about 10 to the 6th power? Okay, at home you should be thinking to yourself, 10 times 10 times 10 times 10, times 10, let me go to times 10. Did I do 6? 1, 2, 3, 4, 5, 6. Okay, now 10 times 10 is 100, 1,000, 10,000, 100,000, and 1,000,000. 1, 2, 3. 1, 2, 3. I'm going to put my decimal point. Now let's count the zeros. 1, 2, 3, 4, 5, 6. It matches the 6 in the exponent, so I feel pretty confident that I am correct. Yay! Okay, guys. See you at school tomorrow. Bye-bye.